NENOMATICA, where mathematics meets YouTube excellence. In this lesson, we will solve the linear floor equation, a times floor of x plus b times floor of y equals k, following a case-by-case algorithm. We begin by displaying the problem and setting the notation. We will use the notation where square bracket x means the floor of x. This is the greatest integer less than or equal to x. For example, if floor of x equals n, then n is less than or equal to x, and x is less than n plus 1. Case 1. K equals 0, and both a and b are non-zero. We isolate terms and express floor of x in terms of floor of y. Whenever a divides b, there are infinitely many solutions parameterized by floor of y. Case 2. K equals 0, and at least one coefficient is 0. If it equals 0, then b times floor of y equals 0, implying floor of y equals 0. Similarly, if b equals 0, then floor of x equals 0. Case 3. K equals 0, equals 0, and b equals 0. The equation reduces to 0 equals 0. So all real x and y satisfy it. Case 4. K is non-zero while a and b are both 0. The equation becomes 0 equals k, which is impossible, so there is no solution. Case 5. K is non-zero and exactly one coefficient is 0. If it equals 0, we directly find floor of y equals k over b. If b equals 0, we directly find floor of x equals k over a. Each yields an interval for y or x provided the quotient is an integer. Case 6. K is non-zero and both a and b are non-zero. We isolate floor of x as a linear function of floor of y. Existence of infinitely many integer pairs follows when k over a and b over are both integers. Here is the consolidated formula for the general case. Let us wrap up with a quick summary. We analyzed the linear floor equation and treated 6 exhaustive cases. Key ideas include isolating floor variables and checking divisibility conditions for infinite families of solutions. For practice, try 3 times floor of x plus 6 times floor of y equals 9. Feel free to ask questions in the comments. Equals 9. Feel free to ask questions in the comments. Example, we will solve the equation 3 bracket x plus 4 bracket y equals 24 step by step, exactly following the structure and logic shown. Here, bracket x and bracket y denote the floor function, the greatest integer less than or equal to x and y respectively. Step 1. Isolate the term with bracket x using simple rearrangement. Step 2. Divide both sides by 3 to solve for bracket x. Note that 4 over 3 is not an integer, so we keep the fraction symbolic. Step 3. Because the floor of x is an integer, the numerator 24 minus 4 times the floor of y must be divisible by 3. So we set it equal to 3k for some integer k. Step 4. Solve for the floor of y in terms of k, then impose the condition that the floor of y is also an integer. Step 5. Test values of k, so that 24 minus 3k is a multiple of 4. 24 minus 3k is a multiple of 4. We will check the smallest few that match the pattern in the reference solution: 0, 4, 8, 12, and 16. Let us visualize the valid intervals for x and y on number lines. Therefore, the solution sets include x in 8 to 9 with y in 0 to 1, and x in 4 to 5 with y in 3 to 4. Both satisfy the original equation. Summary: we used isolation, division, and integer divisibility to solve a floor function equation. We validated 2 solution intervals and visualized them. For practice, try 2 bracket x plus 5 bracket y equals 20. Bracket x plus 5 bracket y equals 20. Thank you for watching. Don't forget to like, subscribe, and hit the bell icon for more math lessons. NENOMATICA, where mathematics meets YouTube excellence.